What's up, young mathematicians? Thank you for stopping by here at Tau2Pi. I am Caesar the Tutor, and today we're going to be doing a few examples on how to do composition of functions. If you want to follow along, make sure to check out the free downloadable worksheet in the description below. And without further ado, let's get started. Let's start with the first example in set 1, f of g of x. And for this one, we know they're simply asking us for f of g of x. So the two functions that we're going to be working with are going to be f and g. And first, let's go ahead and find their domains. For f of x equals root x, all we have to do is make sure that whatever's inside the root, whatever's inside the radical is positive. So we're just going to take it and say x is greater than or equal to 0, and that's our domain. Domain is going to go from 0 all the way to infinity. Now to find the range, remember that this function, the lowest value it can take is 0, or the first actual real value it can take is 0. This function is drawn like this. So this is the point that we need to find. And in this case, that happens whenever x equals 0. So whenever x equals 0, y equals 0, and that's the lowest point. And the range is going to go from 0 all the way to infinity. So I'm going to say range is going to go also from 0 to infinity. Now for g of x, we're going to say g of x equals x squared plus 1. In the domain, well, in this case, it's a polynomial. And since it's a polynomial, we know domain is all real numbers. So we're just going to say domain all real numbers, and we have a negative infinity all the way to positive infinity. For the range, we are simply going to be looking at the vertex, but in this case, this parabola is kind of easy. This parabola jumps up one, and it's graphed like this. If you want to find the vertex, let's go ahead and do that. To find the value of the vertex, we say x equals negative b over 2a. This one has no b. So the x value is going to be negative 0 over 2 times 1, because the coefficient of this is 1. And so we end up that the x value is 0. 0, not x. So the x value is 0. And to find our y value, all we have to do is plug this back in to our g of x, and we say g of 0 equals 1. That means that this vertex is at 0, 1, which means that the range starts at 1 and goes all the way to infinity. And we're going to write it right here. Range goes from 1 and it goes all the way to infinity. Now that we have that, we are ready to begin. F of g of x. So we want f of g of x. And this is equal to f, the outermost function, so that's going to be square root of something. That's the x, that's whatever's in here. And then here's g of x. We can just plug in g of x here and then do an extra step. But why do that? Let's just go ahead and take g of x and plug it in here and say this is x squared plus 1. And the only way we can simplify this is by getting rid of the parentheses. X squared plus 1. Remember that we cannot simply take the square root of this, take the square root of that, and make that an expression. That is not the case. Now let's take a look at the domain and the range of this function, because it's actually pretty interesting. We know that the domain of f of g has to be the domain of g. So it has to be valid for g because g has to be done first. So g tells us that it accepts any input you give it. So we're good on that front so far. Now, based on those inputs that you gave g is going to give you a few outputs. G is going to give you anything from 1 to infinity. And remember that this output of g now becomes the input of f. So we have to make sure that this value is here, which it is. There are no values of the domain that will actually make our range bad here. We can put anything in here that comes out of here, and we will always get a value. Not only that, the smallest value we could get is 1. So now, domain. So the domain of this is going to be all real numbers, because anything that we put in here gets squared, so it loses the positive, and then we're going to add 1. So my domain is fine like it is. Domain is going to be from negative infinity to positive infinity. Domain is going to be from negative infinity to positive infinity. But now if we look at the range, since we know that once we plug something in here, G does it first. You plug it in, G takes it. Then G is going to give you an output. And for now, we know that G cannot give me anything that is less than 1. Any number you put in here, you're going to get something that is either 1 or greater than 1. So then that means that the only numbers that are going to go into F are going to be 1 and greater. So now this right here is going to become the input for F. And based on this input, F is going to give us back an output. And if we look at this right here, we know that F cannot give us anything less than 1 if I don't give it any values that are less than 1. So we're going to say that the output is also going to be greater than or equal to 1. So then the range of this function is going to start at 1, and it's going to go all the way to infinity. The next problem that we're going to be looking at is going to be h of f of x. For this one, we know the outermost function is going to be h, and we're going to be plugging in f of x in here. Now, we already know what the domain and range for f of x are. That's why we did it first, so that we can keep it in a little chart. Because most of the time when you do problems like this, you will be given the same function, so it makes sense to create a little chart where you're going to keep your domain and your range next to it so that you can get to it really quickly. But now we need to start with h. And for this one, well, if you saw the other video where I talked about lines, you know that lines have domain all real numbers and range all real numbers. So we're going to say domain is going to be negative infinity to positive infinity, and my range is going to go from negative infinity to positive infinity. Now, we have h of f of x. So we know that the outermost function is going to be h. So we have h of f of x. So this is equal to, now h is 2x minus 3. I'm going to write it as 2 times something minus 3. And that something is simply f of x. So let's take f of x and plug it in here and simplify. Lucky for us, the only simplification we need here is going to be 2 times root x, which is 2 root x minus 3. Now we have to look at the domain and the range. We know that the domain of h of f of x has to be the domain of f of x, because this function, f of x, is going to be applied first. So we need to make sure to know what the restrictions here. Well, we know the domain of f of x is going to be from 0 to infinity. So we're going to say all the numbers that are coming in here are going to start at 0 and going to go to infinity. But now we have to check and make sure that our outputs don't give us any trouble, or that there are any restrictions on the outputs. And the thing is that the smallest number I can plug in for x is 0. So when I plug in 0 here, I'm going to get 0. And this is going to be a negative 3. Also, this function opens up because that's positive. So that negative 3 is the lowest value. That's what it looks like. So we're going to say that the range is going to start at -3 and it's going to go all the way to infinity. And that should make sense to us because the smallest value I can use for x is 0. So the smallest value that I'm ever going to get for h of f of x is going to be -3. Now let's take a look at example 4, which is g of t of x. We still need to find the domain of that function. So let's go ahead and find it now. The domain is going to be anything that does not make the interior negative. So in this case, we're going to say x minus 2 is greater than or equal to 0. I'm going to say plus 2 plus 2. And we know that x has to be greater than or equal to 2. So we get the domain is 2 to infinity. Given that the smallest value I can put in 2, the smallest value I can get out is 0. So my range is going to go from 0 to infinity. So g of t of x is simply asking us for g of t of x. So the two functions that we're going to be working with are t and g, which is why I found the domain for the last one. And now we're going to say g of t of x equals, well, g is going to be this function here which says something squared plus 1. And t is root x minus 2, so we're going to say we're going to plug in root x minus 2. To simplify, we get x minus 2 plus 1, and finally x minus 1. I'm going to put that here, g of t of x. Now, if we look at this function, it looks like a line. So it would be very easy for us to say, oh, the domain is all real numbers and the range is all real numbers. But this is actually a composition of functions. So we still have to take into consideration the domain of t. And because t is an innermost function. T is an innermost function. So we have to look at t and say, well, no. The smallest value I can plug into this function is 2. Because if I plug in anything less than 2, g, which will be applied first, is going to give me a negative, and this is going to be nonsense, which would make the entire function nonsense. So the lowest value I can actually put in here is going to be 2. So we're going to say domain is going to start at 2, and it's going to go all the way to infinity. Now, based on that domain, based on those inputs, well, the smallest value I can use is 2. And then after that, I can go all the way to infinity. So given this domain, the smallest value I can get out of g of t of x is going to be 2 minus 1, which is going to be 1. So our range is going to start at 1, and it's going to go all the way to infinity. That is all for today's lesson. I hope you liked the video. I hope you learned something. If you did, make sure to hit the like button. If you want to see more content like this, make sure to hit the subscribe button. And if you have any questions, comments, concerns, or emotional outbursts, make sure to drop them in the comments below. Thank you so much.